Wait.
36. The multiplication property of equality. Let's see. Multiplication property of equality.
Why does this look so complicated?
And for this problem number 36, it says if AB is equal to CD, then 5 times AB equals what? Yeah. Yeah. Because multiplication property of equality says if I multiply something on one side, I can also multiply it on the other. Yep. And that's it. You're good?
Well, last time I thought it was hard to fix that. I guess it
Any other questions on the homework?
yeah, yeah.
So the main way we prove a statement or a proof is we're going about and using our properties, the properties that we've had so far, to prove our statements here. Now, so we're going to write the reasons for each step. So if we look at this here, the given, for any proof, we always start with the given information. So they told us that AC is equal to AB plus AB. That's our first line. We always start with the given information. And the last line of our statement is going to be what we want to prove. We want to prove that AB is equal to BC. That's what we want to prove. So we have our given information. Now the first statement they tell us is that AB plus BC is equal to AC. Well, we've used this before, yes? Now this here, if we looked back, it would be our segment addition property. Because the segment addition property states that if we have 3 collinear points and 1 point's between the other two, then the 2 parts add together to give us the whole. That's just our segment addition property. Is that AB plus BC is equal to AC. Questions on this here so far? Now, we have 2 statements, yes? We have that AB plus BC is equal to AC, yes? We were given that AC is equal to AB plus AB. There's one of the properties that we got yesterday that we can use. Because we have that this is equal to AC, and this is equal to AC, yes? So we can say that AB plus BC is equal to AB plus AB, yes? What property was that from last night or yesterday? Yes. It's our transitive property of equality. Because this is going off the fact that angle 1 is equal to angle 2 is equal to angle 3, so therefore 1 is equal to 3. And the reason we're doing it and setting it up this way, because we have AB plus AB is equal to AB plus BC, yes? Well, we have something in common on both sides, don't we? Because here we have 2 of them, but I do have at least 1 on either side, yes? Can we subtract it? Because these here are just lengths. So we can subtract AB's length from both sides, yes? Well, those will cancel, telling me that AB is equal to BC, yes? Well, what do? We subtracted, so this is the subtraction property of so we prove that AB is equal to BC. It wasn't. This is one of the ones we went over in chapter 1, that the two segments, because y'all liked this property because it was saying that if this was 8 and this is 12, we can add the two together to get the whole. So some of the properties that we have from the first section will come back again. And I will have, especially for the review sheet, I will have a list of all the properties and their kind of definitions that will be included in the review sheet. Questions on this here so far? Too far. Here we go. So we're given what? Measure of angle 1 is equal to the measure of angle 3, yes? What do we always start the proof with? The given information, yes? So in this first line, we need that the measure of angle 1 is equal to the measure of angle 3. Okay. Any questions on this so far? Now, they gave us some of the rest of this. So they gave us that the measure of angle EBA is equal to 2 plus 3. Okay. We can see that. They also told us that EBA, same angle, is equal to 2 plus 1. Because what did we say in our given information? That angle 3 and angle 1 were the same. Because we said angle 3 and 1 are the same. So we said that EBA is 2 plus 3, yes? Well, we know that angle 3 is the same as the angle 1, so we could say that EBA is equal to 2 plus 1. And what are we trying to prove? That EBA is equal to the measure of CBD, yes? Commutative property of addition. So commutative property addition says that we can add any two things in any order. So that we can say that the measure of angle 2 plus the measure of angle 1 is the same as measure of angle 1 plus the measure of angle 2. Because that's the nice thing with addition. Is that 2 plus 3 is the same as 3 plus 2. And that is by our commutative property of addition. Okay. Any questions on this so far? So what do you, question on what? What so, which part?
Literally all of it.
Anything. The other part I don't understand is the I don't.
So where are we trying to get to? What are we trying to prove? EBA is equal to CBD, yes. This is where we're trying to go to, yes? So to be able to prove this, I need to show that angle EBA is the same as angle CBD, yes? How can we define EBA? EBA, this angle here, as its part. So what two parts add together? 2 and 3, okay? So if I can get that to be the same as what CBD, which is what? 1 and? So I can if I can define EBA as somehow as the angles 1 and 2 added together, and we can make it the same as CBD, then we can say those two are the same.
Wait, hold up. So, are you adding 2 plus 3?
So the first thing we start off with is our given. They told us 1 and 3 are the same, yes?
Yeah.
So we're going to define EBA first. EBA is what? Angle 2 plus angle 3, okay? So that takes us to the first two steps, yes? Well, we know 1 and 3 are the, so we can replace angle 3 with angle 1 because they're the same.
And then it don't matter how we put it on the
Now, the commutative property of addition says I can add any two things in any order. So we can flip it. to say that the measure of angle 1 plus the measure of angle 2 is the same as 2 plus 1. That's all we've done to this point. But have we defined our other angle, angle CBD? No. But we know that angle 1 plus the measure of angle 2 is the measure of angle CBD. Well, why do we know those two add together to be the whole? Because of the angle addition postulate that we had in chapter 1.
So the whole is 3, right?
So the whole CBD is 1 plus 2. So 3 is over here. Yeah, because those two, angle 1 plus angle 2 is the measure of angle CBD. Those two add together to be that, yes? Now the whole intro, all these first three, is really getting to this here, that EBA is equal to 1 plus 2, yes? Now it says transitive property of equality over here, yes? Now I'm going to get a highlighter. Because we said that 1 plus 2 is the measure of CBD, yes? We also said that 1 plus 2 is what? Because isn't our transitive property if A equals B, B equals C? So A is equal to C? We have that now, don't we? We have that middle part. So we can say that the measure of angle E that's it. So we defined one angle EBA as 1 plus 2. Because of the angle addition postulate, we can say that CBD is also 1 plus 2. Since both of them we've written it or defined them as 1 plus 2, we can set them equal to each other. That's it. Questions on any of this here?
Is it going to get harder?
We're going to look at this one here. Now this one here, unlike the last few, don't give us any of the steps in between. But the first thing we always start with is the given information. So we're going to start off with the measure of angle 1 is equal to the measure of angle 3. And what's our reason? Given. It was given to us. Any of the stuff they tell us is true, so the fact that angle 1 is equal to angle 3 is going to be our given. And we want to prove that DBA is equal to EBC. We want to prove that those two are congruent. So our last step, our last part here, is that these two angles are going to be congruent. Because that's always where we're going to finish. But to do this, we need to be able to define DBA, angle DBA, and EBC so that they're the same. I need to define them so that they are similar. Well, the first thing is we need to define one of these two angles. So we can start off with the measure of angle DBA. Well, what is DBA equal to? What are the two parts? 2 and 3. So we could say that the measure of DBA is equal to the measure of angle 3 plus the measure of angle. And what property do we have that tells us that these two angles add together to be the whole? The angle addition postulate. You don't have to do postulate 1.4, but we just need angle addition postulate. Because the angle addition postulate states that the sum of the two parts give us the whole. Now we need to get to EBC, yes? What two angles add together to give us EBC? 1 and 2, yes? So if I can define DBA as the angle 1 plus the angle 2, then we can say that they're the same. So what can we do? Well, we know 1 is equal to So we can replace 3 with 1. Because we can say that the measure of angle DBA is equal to the measure of angle 1 plus the measure of angle 2. Any questions on this so far? Substitution, property of equality. Now, substitution and transitive, the main difference between the two is substitution, we're substituting one thing in, one value in. Transitive, we're connecting 2 equations together. Any questions on this so far? Have we defined EBC yet? No. So the next statement would have to be what? 2. 1 plus 2. Angle 1 plus angle 2. Which again is just the angle addition postulate. So we've now taken DBA, because it was angle 2 plus angle 3, and rewrote it so that we have it equal to 1 plus 2, yes? We finally defined that EBC is equal to the measure of angle 1 plus the measure of angle 2, yes? So now we can connect those two together to give us our final statement, what we're wanting to prove, yes? By what property? If we're connecting 2 statements together. Yeah, transitive property of equality. That's it.
The only thing I don't get is the reason.
Because these here, yeah, so these here are just the reasons or kind of why we can do what we're doing. So the angle addition postulate, if we add 2 angles together to get the whole, that's our property. That's why we can do that. Essentially, this is our justification. Like with what we did yesterday where we add something to both sides, that's our addition property of equality. This is the same thing, but instead of using just numbers, we're using this here. Any questions on this so far? Now this one here is a little bit nicer. They gave us most of it. We just need to fill in the rest. 6 steps to a 2-proof column are shown. Copy and complete the proof. First one is given. T is the midpoint of SU. T is the midpoint of SU. And we're wanting to get to that X is equal to 5. Yes? So if T is a midpoint, it means it divides the segment into 2 congruent segments, yes? Because we have that also in the homework. If a point is a midpoint, if and only if it divides the segment into 2 congruent segments, yes? So since T is a midpoint, it means that ST is congruent to TU. That's just definition of a midpoint. That's what a midpoint is, yes? So that's what we can say, because I know that about a midpoint. So we know that ST is congruent to TU. That's just definition of what a midpoint is. It divides it into 2 congruent segments, yes? If 2 segments are congruent, it means their lengths are the... So since they were congruent, we can say that their lengths are equal. They're the same. So a lot of these, it goes from one to the next. Because for here, T is the midpoint. Well, if it's the midpoint, it means those 2 segments are congruent. If the 2 segments are congruent, it means they're equal. And if they're equal, here we can substitute their values in. Because for ST, its length is what? 7x. For TU, it is TU plus 20. And we can say,
If you just like the 7x is what x.
because S to T is 7x. T to U is 3x plus 20.
So they're both equal.
If we said they were both 7x, it wouldn't solve it. Because the length from here to here is the same as the length from here to here. But the value of x that goes in there is going to be the same. But the value of x that makes 7x and 3x plus 20 be the same aren't going to be the exact same number. No, you're good. So this here is going to be our substitution. Property of equality. Questions on this here so far? Okay, now we just need to solve this. So what can we do first to solve for x? Minus 3x. Well, they kind of gave us a hint on the other side, didn't they? Subtraction property of equality, I'm going to have to subtract something. So we can subtract 3x from both sides. 7x minus 3x is equal to y, which would give us x is equal to 5, yes? And what goes in the last spot here? And a lot of these here, we take the statements and what we're given as far as we possibly can, and then go with something else if we haven't made it far enough. Because if we think about it that way for this last one, because we start off with the given information, 1 is equal to 3. Can we really take that any further than that? Well, no. So I needed to find something else. So we decided we're going to define the measure of DBA. Measure of DBA is 3 plus 2. Yes? Well, we know that 1 is equal to 3, so we have 1 is 2. Can we do anything else with that? Well, no. Okay. I look back at here. But we also need it equal to EBC. And up to that point, the first 3 steps, we had done nothing with EBC, yes? Okay, so we define it. 1 plus 2. Hey, now they are the same, so we can set them equal to each other. And a lot of times with this here, we're going to take the definitions that we have midpoint and take them as far as we can. T is a midpoint, so it means ST is congruent to S. ST is congruent to TU. Well, if they're congruent, it means they're equal. We can substitute it in and solve. So we try to take the definitions as far as we can until we can't take them any further or until we can't do anything more with them. 3 through 4.
I don't know, that's pretty hard. That's why I did homework problems.
3 and 4, you are finishing the reasoning or statements. So you're filling in the blanks. And that's it. Now, we are going to do more of these proofs on Monday.